So once again, in this block, we assume that our sample is good enough, so it means it's random and representative. And we describe the sample and forget about population for a while. So our goal to summarize the information we have about our sample. Now let's meet the sample. So this is our sample. In this case, again, I use apples, and I have sugar content in 10 different apples, so the sample size is 10 in this case. And you can see that, again, the sugar varies randomly from one apple to apple. So I cannot answer this question directly, how much of sugar we have in these apples, right? So we need to do something with these numbers in order to answer this question. And that's what we call a descriptive statistics. So we need to describe these values. We need to calculate different properties of these values, which we can use later to represent the whole sample. So first of all, and it's a rule of thumb in statistics, always starts with visualization. So visualize the values that you have. In this case, for example, I can use different shades of red, and the darker the apple is in this plot, the darker the apple is, the for example, more sugar it has, right? So it gives you already an idea where you have the most of the sugar, where you have the least of the sugar, and so on and so forth. And the first thing, which kind of natural to do, is to order these values. So I can order these values, I can order the apples. So I have first is the apple with the least sugar, 8.9 grams, and then the last I have apple with the most of the sugar, it's 10.7 grams. So that's what we call a non-decreasing sequence. So it means that every next value is at least not smaller than the previous one. And then below you can see the same, but just the representation of this non-decreasing sequence as a table. And now we can define a very important thing. It's a rank. So every value in this table has a rank. So rank is simply a position of every value in this ordered sequence. So the smallest value, the minimum, has rank of 1, and the largest value has a rank of n, where n is a number of values. It's a sample size. And then we can define a middle point, which we call a median, which has a middle rank. So it means that it's located exactly in the middle. So 50% of the values are smaller than the median, and 50% of the values are larger than the median. Because in this case, we don't have a particular value for the median, we have two values in the middle, right? We simply can take a point which is equally distanced from these two. So you can see that the distance between the point number 5 and 6 is 0.1 gram. So you take a half of it, and it will be 0.05, and then you simply add 0.05 to fifth value, or you subtract it from the sixth value. So that's the point in between, right? 9.85, and that's the median. Now, if you think about these values as an interval, so these values vary randomly up and down. So in this case, the median, it's a measure of center. So it's where the center is, where the center of this interval is. While the minimum value and the maximum value, it's the measure of spread. It's how big the variation is, how far values can go from the center. You can actually compute the difference between the max and the mean, and that's what we call a range. So range, it's a measure of variation of your values, while median, it's a measure of the central point. Okay. So now we can answer the question, how much of sugar in apples? You can say that the median content of sugar is 9.85 grams per 100 gram of total mass, and the total sugar content in sample varies from 8.9 to 10.7 grams with a range of 1.8 grams. So you already can kind of summarize, and it doesn't matter how many apples you have, hundreds, 200 apples, 30 apples, 5 apples, you can always summarize all these values into these two statistics, right? So in this case, it's 4, of course. But if you think about median and range, it's two statistics. One statistics tells you where the middle point is, and the second statistics tells you how big the variation is, how far values can go from the middle point. And now you can also represent this as a plot, and this is the simplest plot you can make when you have just one variable and a sample of some individuals. That's called strip chart. In the strip chart, you have only one axis, it's x-axis, and then every location of every point is simply a value of these characteristics that you have as x-axis. So in our case, it's sugar. So you can see, for example, the values vary. Most of the values are located in the middle. We will observe this trend like a it's called central tendency, where most of the values are located in the middle. For most of the experimental data, we will discuss this trend quite thoroughly in this course. And then you can see, for example, this is the smallest value. The two dashed lines are the smallest and the largest value, and the dotted line in the middle, it's exactly where the median is. And then you can see, indeed, we have 5 values below median and 5 values above median. Okay, so this is the representation of the statistics that we just calculated. Variation spread is simply a distance between the maximum and the minimum value. That's what we call range. And then median, it's a center of this values. It's where the center of this interval is. So now you know two simple statistics that describe your values and help you to answer these questions. In this case, it's how much of sugar in apples. It's a median and range. In the next video, we will generalize these two statistics, which help us to make even better description.